Hello, welcome. You can see me now, right?
Yeah. Hello.
Uh-huh. Hello, Ramya.
Hello.
And I can see Chris and all right? Okay, some more coming.
Yes.
Hello, glad to see you.
Hello.
Hi.
Thank you.
So maybe let's get ready, right? You can see my links, I think. All right, so I now copy here to the chat area. Right. So maybe you can go from there to the materials I set for today, okay? So here we have another workshop. Yeah. And so now for today, I have a specific topic, right? So I would like to do trigonometry, right? Also partly because of the previous recent Halloween, okay? And so I call it trick or treat, okay, sections. But at the same time, actually, I prepared to talk about a specific topic, okay? Instead of just talk about the tools, the GeoGebra or the decimals, right? And I will use both today, depends on how much time we have, okay? But the main point is, okay, it's fine, all right. And so the main point here is that we will use the two materials, two set of tools, and looking at the specific ideas in trigonometry. All right, so if you click on my link, the first one, I think you can see the GeoGebra task. You can click on this link. Okay, are you following me? Can you find this? Can you find this page? So can you find this page? Which is about unit circle, specifically about unit circle. Do you have to teach this topic? May I know?
Yes.
Yes, got it.
I see. So this is one of the topics that we may teach in the DSE or the IB curriculum, right? So today I just focus on this very specific piece of ideas about unit circle and definition of trigonometry. Now, for the entire books, you can actually find more sections starting from right angle triangle, right? But I just focus on only one set today. Okay, just talk about the unit circle. And so you can find different materials I provided, right? And my approach may be a bit different from the textbooks. So you may share with me if you have similar experience or not, all right? First of all, I would like to share with you my teaching approach. So you can see this link here. In fact, I'm glad to find this book online. Okay. So I'm glad to find this book online. Maybe you can click on this and then you can have a look of this book, right? Which explain quite well my preferred approach, okay? Which I'm afraid that it may not be common, right, to in many textbooks, right? So I copy the links here as well. Does it work? Let me see. Maybe you can try, or you simply go to my workshop page, okay? So this is the workshop page. Maybe I copy again while I see some one more coming, okay? So you can come to my web page and click on the Google GeoGebra task and this page, then you will open this GeoGebra task. This is one of the GeoGebra book, which I focus only on one section about the unit circles and trigonometry. And to begin with, I talk about my approach. So you can click on this book of Sawyer, okay? And if you click on this, you can see the original page in the Internet Archive. So which is a very nice platform actually, okay, for finding some old books. So this chapter seems to be about algebra, right? However, if you scroll down, right, you will find out more. And in the middle of this chapter, then you will see something about trigonometry. So we already captured here, okay? Now, one point I would like to highlight, first of all, is that we talk about, okay, when we talk about trigonometry in linear form, that means when we talk about trigonometries of any angle from 0 and 360 degrees, okay? And one of my approach is to emphasize that it is a kind of conversion between rectangular coordinates and polar coordinates, okay? And that is particularly useful, I believe. Although, unfortunately, in the DSE curriculum Hong Kong, okay, we may have to forget about the polar coordinate in the new revision, right? However, even though we may not explicitly talk about polar coordinate, right, I think we can still mention this basic idea. I just like what the author mentioned here, right? That means if you look at a point in the plane, then you can look at its rectangular coordinate, but you can also look at its angle. That means the direction and distance from the origin, right? And the conversion between these two is the fundamental idea, okay, between trigonometry and the other ideas. And so I would like to use this as a starting point, okay? So this is also some teaching approach that I will promote and suggest to you. You can also compare that with your textbook, see whether it's similar or different, right? I believe that is not quite common in Hong Kong. And later on, they also point out that in order to introduce this new definition, we simply assume that the sine and cosine ratios or values are the coordinates of points on the unit circle, right? Is it how you learn about trigonometry in school? Is something you learn about it? That means you just assume that the sine cosine values are the coordinates of the points on the unit circle. I'm not talking about ratios. Okay, I don't know whether this is the way you learn it or not.
Yes. Yes.
Yes. Oh, okay, good. But if you try to look at the books in Hong Kong, it's not like this. Okay, because it's we start from ratios, right? We just talk about we treat it as a kind of ratios. Okay. Oh, it's interesting. Maybe you can share with us later, right? How you understand it, or maybe if you have a chance to talk about the teaching and learning, then you can further discuss it. Now, anyway, my emphasis is here is that the sine cosine are just the points of coordinates, right, in the unit circle. And so this is also explained by this author anyway, okay? But it can be extended, of course, right, by just treating it as a point in the unit circle. Then you can talk about it generally and how you can describe position of points which is not on the unit circle, right, based on the coordinates sine cosine of an angle. Okay, now, so this is a reference for you to consider if you want to look at my background of my teaching approach, all right? And how we do it, let me show you some of the approach materials I use to compare with. For example, I go back to the GeoGebra page, okay? Can you see this? Maybe I copy it for your convenience, all right? I put it in the chat again, right, for the convenience, right? Or you can come from my homepage, okay, this part, and you can see this book. All right. Now I click on the second one. Right, the second one is the definition, right, that we see, okay, perhaps in Hong Kong or in many books. Oh, this is a very nice applet, okay, designed by a teacher in Hong Kong. Right, and so you can see very clearly how the point can move on the part of the unit circle, and this is the angle, and you can also see sine, cosine value, but you can also notice that based on the definition in common Hong Kong textbook, right, they will treat as a ratio 0.77. That means the x coordinate, sorry, the y coordinate divided by the length OP, right? Even though of course in this case OP is equal to 1, right? So it happens to be exactly the coordinates of the point on the unit circle, right? And similarly, you can see the other information, okay, that you can find, and you can also turn it into 4 quadrants and zoom out, okay? Then you see a very nice picture, okay? Now this will help you to remember, well, maybe the definition, but my emphasis here is not simply remember the definition, right? So I now go to my other applets in my book here. I would like to start from this one, okay, rectangular and polar coordinate. I just name it conveniently to say that it is about rectangular and polar coordinate, okay? However, I don't really directly describe the polar coordinate, okay? So it's up to you how you describe it. And so you may simply say that it is just recognition of the distance, d, or this direction, right? You can call it theta in this diagram, right? So for any point P, you can determine its direction, right, from the x-axis, positive x-axis, okay? So this is still useful. And so that means in some cases, right, we may have, of course, we may have the x and y coordinates, okay? Most of the case, we know the x and y coordinate, but we may want to turn it into an angle, right, to express it as a direction. and also the distance from O. Okay, then how can we do it? This is starting point. Okay, the point is how can we do it? So basically, we can refer to the coordinates on the unit circle. Right, that means here if you enlarge it, then you see that the point should go through this this point here on the unit circle. Okay, so based on this, by multiplying d, okay, that means the length, then you can obtain the coordinate, the xy coordinate. Okay, and the other way around, if you use arc cosine or arc sine, that means use a calculator, then you can find the theta as well. All right, and you can in fact practice here using the calculator. Right, that means, for example, if you wonder how you can get the sine ratio, then you can just input 2, which is the y coordinate here, divided by the distance 2.24. That means check how you can get this value using a calculator, but you have to use the approximation sign in order to get this value 0.89. Okay, so can you find my file? Can you see how you can operate in this manner? All right. So I will basically start with these questions on how to convert between the rectangular coordinates and the polar coordinates, or maybe you can say that means the direction and distance. Okay, how to convert between these two. Particularly, for example, I just moved the point somewhere here. So I use the checkbox, so you can see that to hide or show different paths. Okay, so if you don't have, let's say if you don't have this x and y coordinate directly, but you know the length is 2.2. The angle is 35.5 degrees. Okay, so you know that you can know this angle here, right? Can you find out the x and y coordinate here? Okay, by the calculation. Okay, so the sine and cosine ratios will give you the values. All right, so you can also practice here. For example, 2.2. All right, multiply cosine. Okay, so you can press here 35.5. Now you may wonder where you get the degree. Oh, sorry. I have to scroll up a little bit. Right? Can you see the keyboard? The lower part, right? You can open the keyboard and then find out not this part in the FX keyboard. Then you can see the degree button, right? You click it and you add the degree sign here. All right. So enter. Oh, you have the exact value. Sorry, you should use the approximation sign. Right, to give the approximate value 1.79. That means the x coordinate will be 1.79 around here. Okay, so you can check it. Okay, so do you see how it works? All right, or you can directly get the sine and cosine ratios, right, by calculator. That means you can skip this part. Maybe just multiply 2.2 by 0.81. Right, then you can check this value as well. Right. So let the student practice the basic calculation in order to get used to the definition. All right. So that is something that I suggest. Okay. Is it clear to you about how we use it? All right. Or you can also use in this way. Maybe now you can hide the value, or you can hide the mark here, and then you can hide the angle. Okay. And then you can ask the student to guess whether you know the sine ratio is positive or negative. So I hide this part now, okay? Because usually at the beginning, the student may not be so used to, okay, thinking about the sign of the cosine and sine value, all right? So if you put the point here, then you can ask the student, can you guess, all right? Or can you identify the sign of the sine and cosine ratio, right? That means sine theta, cosine theta, or even estimate the value by looking at the unit circle, okay? So you can try both. And then let's see how far they can estimate the value. Okay, so that can be used in this way. Okay. So any questions about this applet? Vivian, are you saying something? Yes. Maybe Vivian, all right? Because I see her talking first.
Okay, so I clicked on that link which you put on the chat, but I cannot get this. I cannot get this page like this.
Can you see this page?
Yes, I clicked on the second one.
That is the fourth one here.
Fourth one or the fourth one? Okay.
The fourth one here, rectangular and polar. Can you see this one?
Oh yeah. Okay.
Right. You can
So,
find
but,
this one.
okay, now I can find it. Okay.
Yeah.
Okay, I was going on the second one.
Oh, I see. Yeah, because they're very similar. Yeah, you're
Mhm.
right. And so, I start this one first, and then I jump to this one, right?
Oh, okay, fine.
Yeah.
Okay, thank you.
And yes, hey, Sean?
Totally.
Yes.
How can we check the students' understanding if we're using this activity?
Now, when I start using it, right, I suppose it is mainly for the teachers' projections on the screen and then asking various questions, right?
Okay.
And to get them maybe and practice. I mean, I say practice, but practice in a very simple and casual way, okay? Not simply do a lot of calculation. In case you want them to, let's say, do some calculation. What I just a quick suggestion, right? Maybe you can ask them to use the whiteboard, the mini whiteboard that I try in the classroom.
Sure.
Ask them to write down quickly how to get away. For example, if you take away, let's say, okay, take away x and y value, right? Then I will ask them, how can you make use of this number to find the x, y coordinate? Okay, ask them to write it down, and then, or maybe just describe it, because they can just say 2.2x times 0.61. You see that? Okay, so
Yes.
you can also practice orally. This can be
Okay.
one way that you can try it out. Of course, you can think of some other way, all right? Because there
Sure.
can be more than one way to do it. And I also show you at the beginning that in the GeorGebra platform, you can turn it into GeorGebra lesson, okay? And then if you turn it into lesson, then share the links with the student, then you can see how they may be doing individually, okay? But of course, this object, this applet is not designed originally to be used in this way, okay? But still, you can turn it into an applet and then invite them to try it out on their own in a casual way, and then report to you how far they can find out the x and y coordinate, or maybe how to find out the cosine and sine ratios. For example, based on this information, you should find out sine ratio and cosine ratio. Can you follow me? Right. So for example, if you look at this, then theoretically, they should be able to tell you how to get the sine theta and cosine theta, right, in this case, okay? So that is one way that you can practice it. But my point is still about introducing the basic definition of sine and cosine, and also the purpose of doing it in this environment. So I don't simply tell them that this is the definition and then remember it, okay? I'm talking about how to make use of it, okay? That means convert, right? For example, to convert the information about angles and length into x and y coordinates. That can be one way to see the purpose, okay? And particularly if you tell them that this is how the computer can handle the graphics, right, then this is also relevant. Because for the computers, theoretically, when you tell the computer, I want a point in this direction, and I want a point at this distance from origin, then they will do the calculation to convert it into x and y coordinates. Right? Do you agree? Right. So that is the way I will introduce the trigonometry ratio. The trigonometry definition. So any other question you have? Now, how about we try another one? It's just the next one, rectangular versus polar. But I changed the setting or in the coming one. And so maybe I go back first to let you know that we have two more like this, okay, on my screen. So the next one here, down here, can you follow me?
Yes.
You click on this, then you find this link, and then I also share with you the link. I put it in the chat as well, okay? In case you don't see it, all right? Now, so this one looks like the previous one. So this one looks like the previous one, but now you can't see the point P, or you cannot control the point P directly, okay? You can't, sorry, can you move it? Oh, you can move it. Interesting, I forgot that. Okay, you can still move it. But at the same time, you can also generate a new point randomly by clicking this button, okay? So you can have a try. So for example, if I click next, then you can see that a new point will be created. Do you see that? Okay, and I can hide the point, hide the angle, okay? Hide the x and y, sine and cosine ratio, okay? Now, If I click the point, you don't see it directly, right? Then I can start asking the student, where is the point? Okay, for example, which quadrant is the point? Okay, so of course you can make use of this, okay, to ask the student, or maybe this, okay. So particularly the student may not be so familiar with the angle at the beginning, then we can ask which quadrant, right? Or you can ask the student to put the hand in front. I just show 1, 2, 3, or 4 fingers, all right? And then just quickly show you. Now, this is what you can do inside the classroom, right? Ask them to respond directly. Where do you think the point is, in which quadrant, okay? So you can see, you click upon, then you can see the point is here in the third quadrant, right? So I do it again, then you can see a new number and new point is already generated, right? Then you keep asking, which quadrant do you think it is? Or you can also ask, so what is the sign of the cosine ratio? That means cosine theta or sine theta. What is it positive or negative? So you can also ask them to suggest, right? Then you can see whether the cosine or sine theta is positive or negative, right? So that is another way to practice or to get used to, right? Or get familiar with the new definition, particularly recognizing the sign of the cosine and sine ratio. So that is one way that we can use it. Is it clear to you? Okay. Can you see how it works? Right. Or you can freely suggest other ways of using it, right? If you think of any other ways of using it in the classroom, right? So feel free to discuss with us. Now, I already prepared a video to show you how to make this file. So you can go back to the previous page. This is the first one, all right? And if you scroll down, you can see the video, right? And so I don't show you the steps now, but if you look at my video, then you will you can follow step by step in making this file, including the second one, right, that allows you to generate randomly a point. Okay, so I don't do it now within the workshop. Is it okay? All right. Okay, and then let me show you, go back to the front page of this section, the unit circle. All right, and then let me move down. Now, I would like to talk about some other way of understanding or recognizing the definitions of sine and cosine in this environment, like in this relatively new environment to the students. Right? As I mentioned earlier, okay, so you can see this file, unit circle pattern 1. Okay, it will show you and some other things that you can do with the unit circle. Okay, so I click here, and then and also I copy the links in the chat area. Okay, can you find this one? Now this one, I also give you a video, right, to demonstrate how to make it. This one is relatively simple. Okay. And you can see basically in the graph here, I have 2 points, A and B. A is 1, 0, B is 0, 1. Right? But if you click inside, then you can see the definition, right? Cosine theta, sine theta. And where theta is something here, right, that you can change. Okay. All right. So I just move it back. Okay. And if you click on the style bar, you can also change it to the definition. Then you can see that A is actually cosine theta, sine theta, based on this value theta. And B is another point, okay, theta plus 90 degrees, theta plus 90 degrees of sine and cosine. That's why you have the point B here, all right? And I joined them by segment, all right? And while moving it, you can also see the trace of the segment, all right? Now, in this way, we can encourage the student to experiment with different geometric patterns, okay? But at the same time, it is also a way of practicing the use of the sine and cosine ratios in the new, according to the new definition, okay? Particularly when we are focusing on the meaning of the unit circle. Can you see this? All right. Now, maybe we can go through some steps together to experience of the way of making it. All right. Do you have the GeoGebra applets ready in your desktop? I have this classic 6. Okay. You have a GeoGebra applet?
So we
Ready?
have to go to a new page
Yes.
now.
Yes, yes.
Oh.
If you are in the website, then you can go out, right? And then you can see the, yeah, you can see the, I mean, the GeoGebra Classic, GeoGebra Classic. That is the same, actually. Okay, I can start here anyway. Maybe I can start here. Can you do the same?
Yes.
Okay, now, so basically you have the algebra window, right? Up here. So you can click on this. Let me see, move up a little bit. Can you see? Okay. So you can click inside and to introduce a variable theta. So you can use the keyboard, right? And find the Greek alphabet theta. Okay. Don't worry about the curve, right? Because they may not know what you're going to type afterwards, so they give you a curve, right? But actually, you will continue to type equal, okay? And then let's say 30, just keep any number you like, but you want it to be in degrees, so you come to this page, this tab, and then find the degree sign, okay? After finish it, you can enter. Okay. Can you follow?
Thank you. No.
Can
Okay,
you
I try
repeat
again, don't worry.
Sorry.
So I can try again. I just delete this part, all right? Can you come here? Are you ready?
Okay, yes.
Okay. Use the keyboard, lower left. Can you find it in the lower left?
Yes.
Okay, use the keyboard. Then you can find in the ABC tab, but in the Greek alphabet, and you can change the Greek alphabet. You see
Mhm.
this? Okay. Okay, so you can, if you can change the Greek alphabet, you can see theta.
Oh, okay.
Okay, and then just type equal 30, or you can come to this, or you can also use this keyboard as well. It's up to you, all right? And then finally, you have to make degree, all right? Give a degree symbol. So you come to F of X page, this one, and then you can find the degree symbol. Can you do this?
Okay, yes.
Okay, then you can press enter. Right? You can use the keyboard, your own keyboard or the virtual keyboard, all right? You see this? Now, you don't have simply a number. You should have a slider as well, because they will assume that you can change this value, okay? Even though you input 30 degree, right? However, they will give you a slider from 0 and to 360 degree, okay? You can drag it and then to see it. Can you see this? All right. Now, if you click the circle, then you will see the objects appear on the graphic window. Right-click it. If you want to drag it around, then you can right-click it, okay? So you can put it in the graphic window or just leave it in the algebra window. It's up to you. Both sliders are the same, actually. Any question up to this part? Okay. Now, can I continue? Is it okay? All right. Then the next thing I would like to do will be, let me see what, oh, I want to point here, right? And described by cosine theta, sine theta. So I simply input let's A equals, and then start input the coordinate. The coordinates are cosine theta, and go to the keyboard to find theta again. So this is theta. All right, you see that? You don't have to press degree because theta is already expressed as an angle in degree. Okay, so just write down cosine theta, and then comma, and then you can continue to press sine theta. Use the keyboard again, theta here, right? Then you will have a point somewhere here. Do you see this? Right.
Yes.
So you can scroll to zoom in, choose the point A, and change its color if you like. All right. It's up to you. You can change the color to distinguish it. Right now, if you drag the slider, the point A will move around. Now that is coming back to my original suggestions about the meaning or the definitions of sine and cosine. I would simply say that cosine theta and sine theta are the point on the unit circle, right? Are the coordinates of a point on the unit circle, right? Of course, you can even draw the circle actually, okay? So if you click on the circle with center and radius, you can start with 0, 0. Okay, and then let's say give the radius 1. Right, then you will see the unit circle. Right. So that means to me, at the beginning, A or cosine theta and sine theta are just coordinates of a point on the unit circle. And they can also see how it works, because when I change theta, then you can see the value change, all right? And later on, you can use it to define distances apart from those on the unit circle, right? That means you talk about points that are further away, then you just scale it up, right, by the distance from the origin. Then you will use, then you can get coordinates of any point away from the unit circle. Okay, go back to our construction here. I think you're ready for the next point. Am I right? So
I have a question.
Yes.
So when you put A cos theta sine theta, how did you get the point A on the graph? Like, how do you do that? How do you plot that point A? You just
Enter.
enter?
So if you just type in the algebra window, you finish it
Okay.
and then you enter. Okay, then the point should automatically
Appear. Okay.
Yeah, you finish it, you just type enter, then you will
Okay.
have the point. All right. Now
Okay.
maybe we try again. So maybe here I further down. Okay, I use the points, create a point C. Okay, which is cosine and also theta. Oh, sorry. Cosine bracket, and then inside the bracket I use theta. Can you see this?
Mm.
Okay. Now maybe this time I add 90 degree to it. Right. Don't forget the degree sign now. So I go back to this one to get the degree sign. Can you follow?
Yes.
Okay. And then move further outside the bracket. Sometimes I cannot easily press it. You just use the left right button in your keyboard. That will be fine. All right. Okay. Comma. And then second part, sine. Right. The y coordinate will be sine theta. Okay. Also plus 90 degree. Okay. So I finished now. So I can press enter or use your own keyboard, right, to press enter. Can you see this?
Yes.
Okay, so when you finish it, then you can see the point C. Maybe I mark it with another color. Okay. So I have a point C, which is at the position theta, that means 60 plus 90 degree. Okay. So another point on the unit circle. That's why you see another pairs of coordinates. Okay. And basically, cosine of the angle should be a coordinates of that point. Okay. So once again, I emphasize what sine and cosine mean, but at the same time, I'm helping the student to draw points on the unit circle. Of course, later on, you will see that I can create patterns, right? So that they will find that drawing may be interesting. That means the drawing itself is also meaningful, right? It's not simply just practice in a boring way, remembering the definition, all right? And then you can also see the symbol like this, cosine theta plus 90 degrees. So this may look complicated at the beginning, but now if we get used to this definition, then you will know that this is just another point, okay, rotated by 90 degrees, right? Okay, now I just continue. I don't worry, I just switch on the video a little bit, but I can continue on my screen, okay? And now, so if you drag the slider, do you find that A and C both move? Is it what you see?
Yes.
Okay, so this one now, basically it's done. You can now go to the segment, join A and C. Okay, so you can create a segment. Maybe I can turn it into another color. If you don't need the circle, you can hide it. Right, you can use this circle. Click on this, and then you will find that the circle will be hidden for a time being. Okay, and then we drag the theta slider, then the line will rotate. Okay, do you see that? All right. Now, finally, you can click on the line, right click, and then to find show trace. Okay. And you have this, then now you can see the effect of turning the line on the circle. Do you get it? Okay, can you get it? Now you may find that there may be too many points. It's up to you. If you don't want to so many points. By the way, when you just scroll up, out and in, just like what I'm doing, then the trace will be gone. All right, and so you have to drag it again to create a trace. And the same time, I would like to let you know how I changed the slider. If I click inside here, I do it again. Just click this number or this number, right? Either the beginning or the end, okay? And then you will see the option for you to change, all right? Now the step here, actually, now you find that it's turned to the radian, actually, okay? And so you may want to change the step to, let's say, 10 degree, okay? But you need the, oh, let me see, where's my keyboard? Can I find my keyboard? No. Why the keyboard is missing? Oh, okay, it's here. Only when I click here. Let me try again. Okay, I think it worked. So I see that. You have to come to the algebra window first, and then you can see this keyboard. Okay, and then maybe you can now click on inside, and then you can change it into 10 degree, 10, but use the degree sign. All right. So they will increase in steps of 10 degrees if you press enter. Now, if you drag again, and you'll find that it now increase in steps of 10 degrees. It may be a bad picture to look at. And you can also see the changes, right? Quickly, in a more clearer way, okay? And something about the algebra window, if you click inside the algebra window, I click inside, right? And then you can see the style bar. All right, and here you can choose to show the values only. Then you can see maybe a better picture, a better view of the numbers. All right, and you can use it to change whether you want to show the definition or you want to show the value, or you want to show both. Okay, you can experiment with this. Okay, in this way, when I drag the values, then they will only see the values changing, okay? And hope that they still remember that these are the X and Y coordinates. Right? And one more things about the algebra view, while you have the style bar open, then you can find that you can rearrange the objects, right? According to different criteria. Maybe you can put it into different object types. So then the points, you can hide the angle or you can hide the circle, and you can also hide the segment if you don't want to show it here. Then you can focus on the points. All right. Actually, point B is not. We are not focusing on point B. We're focusing on point A and point C. Okay. Can you see this? Is it clear to you?
Yes.
All right. Now, how about we do some more different kind of drawing? Once we have this the point defined, let me show the definition again. I show the definition. Okay. Now you can change the definition of the point C to experiment with the drawing. Okay. For example, let's say if now I want to emphasize that the point, actually these are the coordinates, right? I can multiply my coordinates by 2, right? To go back to my previous demonstration, how we can create points outside the unit circle. Basically, we just multiply sine and cosine by a certain value, so representing the length. Okay, so in doing so, you can also see the effect. Okay, I enter it now. Okay, you can see the point C, okay, becomes longer, further away from the origin, right? And if you drag it, and you have a slightly different pattern, right? So you are experimenting with the drawing and also trying out how you convert the coordinate or maybe change the coordinates, all right? And then get used to thinking about how the coordinate will be modified. Do you agree? Okay. Of course, the simpler one will be simply just 2 cosine theta. And for basic comparison, right, then you may want to compare this, but the drawing may not be so interesting, of course, right? but it's a way to try it out what this means, okay, what this calculation means, okay? Or you can just add 1 to it. Can you imagine what would it look like?
Oh,
Do you know why?
that's fun.
Okay, can you see why it's changing this way? Okay. Okay, then you can imagine why the point C, okay, becomes like this. Right, okay, something like that. Actually, C is rotating on the circle. Can you roughly see the circle here? Okay.
Yeah.
But if you look at this as a coordinate, then I think it's easier to understand why it works. All right, so you can actually you can freely encourage the student to play with the numbers, right? Play with expression and then try to generate different kind of patterns or drawing. And if you want to get something more interesting, actually, I would suggest you to try this one. Do you know what happened? If I try 2 theta, do you know what will happen? So the point C is here.
Area is getting bigger, or the line is getting.
You see how it works? Okay. You can change the step, maybe this time, maybe you want to have more steps, okay? Then I would like to, oh, I have to use the button again. Okay. Enter. Okay, then I have more points. You have to check it slowly. All right, so play with it. All right, try to see how it works. Right, and then you can imagine other kind of pattern that can be created in this way. Okay. So finally, if you look at my page, I think it's like that. There's it. I page on the unit circle. Yes, this one. I have the slider. I put in another graphic window above, all right, which is much longer, and then it's easier to manipulate, right? So you can have a try, and we will quickly show you how we do it. Because when you open the view option, then you can see the graphic windows too. All right, so you can have a graphic window too, and you click it. Actually, you have a new graphic window besides. Okay, and click on this button, the arrows here, to move it to different position. So in this case, I drag it somewhere above these 2 windows. Okay, you see this? Then you will have a graphic window. This is another graphic window, right? And you can put things here in the new graphic window. And so now I can put the slider. I can right click and change the setting of the slider. In the advanced tab, you can see graphic 2. That means it will appear in the graphic 2 as well, okay? And you can take away graphic 1, so it won't appear in graphic 1 now, but only appear in graphic 2 and also in the algebra view, okay? So, and in this way, the slider will be put here, and you can change the length. I open the setting again. In the slider part, you can change the width to, let's say, 1000 if you want it longer. Then it will be a longer slider, right, on top, right? And finally, you don't need the axis, so you take it away and then change the color of the background. That will be better. All right, that is how it works. I can create another graphic window above, which is the same as this page, somewhere here. Okay. Is it clear? Right. So do you have any question?
No, but it will just take a while for us to learn.
I have also the video here. You see the
Oh,
video?
okay, okay.
Yeah, you
Okay,
can.
so
follow
we
this
can,
one.
based on the video, we can follow the
Do the same.
steps and
Yeah,
yeah.
the
Okay.
same step. Yeah, you can check
Okay.
it. Although this video is silent, because I want to-
Okay, okay. But at least we can see sequentially which step
Yeah.
comes, right? Okay.
And I call it stitching. Do you know this word?
Stitching, yes.
Stitching, okay, some
Yeah.
kind of stitching, okay, and weaving, that means just making
Mm.
straight lines, okay, and making
Mm.
patterns. So you can try this one. All right, maybe let's see one more. Now the later one, basically, based on similar idea, all right? And then one more part, maybe I talk about the symmetry, all right, circle, unit circle and symmetry. And here, I use it to talk about the relations between certain angles in the rectangular coordinates environment, right? Particularly when you look at this 4 point, right? Their coordinates are closely connected. So if you look at the label, that means the coordinate. Okay, then you can find they are closely related. Okay, and this will help the student to understand in what way some angles are directly related. That means their sine and cosine ratio can be the same or just opposite. I use the word opposite, not negative. All right, because it can be just simply the opposite sign. Or it's not about whether they are exactly negative or not. All right, so you can change to this side, then you can also see the point. All right, now this is the movable point. Only one point is movable. If you want to distinguish it, then use the different color, right, to distinguish it. This is the movable point. Not just for these 4 points, but also another 4 around here. All right, and then altogether, these 4 points have the same set of x and y coordinate, either the same or opposite, right, or swapped. That means x and y coordinates swap. It is based on the symmetry of the x-axis and y-axis. And you can use it to remember how the sine and cosine are related, or you can use it as a quick quiz, right, to test your students' understanding as well. Okay, so I make this one to emphasize that this is more about the symmetry. That's why I talk about symmetry. It's not simply remembering a list of formula, all right? Cosine 90 degree minus theta equals to blah, what and what, right? But rather it is remembering how the points are related on the graph. And you can even try different kind of emphasis, right? Just like this one, I emphasize a reference angle. That's why I draw this triangle. Or I can use the cross, okay, to talk about another kind of symmetry. Because if you look at these 2 points, right, and then you can see that, oh, sorry. So I should start with the label. Okay, then the coordinates are swapped. And these two, similarly, if you look at these two, this pair, right, the coordinates are also swapped, right? So, or this one, you should compare with this one, actually. Okay, so x and y coordinates interchanged. Okay, so and you can play with another kind of relation. These are 2 square, right? Each one's rotated by 90 degrees, either clockwise or anti-clockwise. All right. So that will make it as a whole. Right? And maybe one way to remember how there are different angles on the unit circle, right, defined by the symmetry according to the axis. Okay. So that is one way that
color. Sorry, does it color automatically? How do you color the squares? Oh,
I create a square. I create a
Oh.
square and then
Okay.
change this color. All right. For example, maybe I stop it. Okay, now I can show you how to make a square. Simply draw a polygon.
Okay.
Join the point, then you have a square.
Oh,
Okay. And for the square, now change the color. You can also change the opacity. Okay. And finally, use the checkbox. This one, the checkbox. Here, you can say square. Give a name and then try to find out so which one they control. I can't see it. Maybe I have to move it up above. Oh, sorry. And so I can see quadrilateral. I guess maybe this is the new one or the other one. Oh, you can choose the object anyway. Okay, let me try this one.
okay.
Use the. Okay, yes, that is the one I'm controlling. Okay, so I have a try. Right, for some of the details, maybe you have to experiment on your own, right? But basically, I'm talking about the symmetry of the points. And another one, the next one, if you click the next one down there, you'll find very similar, but I make it, I elaborate it, right, so that it's easier to move. And also, you can invite the student to put the point, okay, in one of this corner by changing these values, okay. For example, if I change this to, I click inside and then change this to plus, enter, okay? And this one also changes to plus, enter. Then the green point will go down here. Okay, can you see this? So you can, now you can invite the student to put the points in different corner. Now you can create a lesson. Actually, this time you can create a lesson and then ask the student to do it together and then see whether they can create correctly the values, okay? Based on the theta. Theta is given here, 37 degrees. And then you just input the value according to theta. Can you see that? Or you can also simply write down negative A, sorry, and negative B. Okay. Because I have the A and B also defined here as well. So if you enter negative A, negative B, the point Q should be here, opposite to the point, the red point, all right? No matter how you move it. Okay. Okay. Can you see how it works? Right now, this one it could be used maybe for practice, right? Or maybe to have a shared practice with the students as well, right? Right now, that is more or less I would like to demonstrate with the GeoGebra, right, so far. And maybe I can move to Desmos, right, to let you know how I can do something similar in Desmo. Right? And so you can click on my links, my page to find out the Desmo activity based on unit circle, part 1 and part 2. Okay, maybe I click the part 1 first. And I can also show you the, the link. All right. So I put it in the chat area. Now this is a set of activity I designed based on the same principle. Although the technique is not the same because we are using another platform, right? But the design, I mean the teaching idea is the same, okay, in compared with the one in GeoGebra. And I also really tried with some students. Okay? You can click, you can just preview it, right? Just click on this. Now you'll find that I use the table, right, and ask the student to input the value one by one. All right, so they can directly input cosine and sine of an angle. Now in this way, I'm asking them to practice using the sine and cosine to describe points on the unit circle. Okay, do you see that? All right. And so they can do it on, I set up different questions. For example, this one, I asked them to amend this figure because it's not a regular figure, right? So they have to find out which one is wrong. So maybe they can recognize the second point, then they can check it. Is it the second point? Okay, can you correct it? All right, so that it will be more symmetric. All right, so what should it be? Any suggestion from you? Okay, yes. Can you see it?
45.
45, right?
45.
So then you can type it, right? So let the student practice, right? What it look like. Now, can you see that? Right, so it's very simple. So you can amend another point and so on, right? So I asked them to do it, and in order to demonstrate how they may understand this figure and also understand the meaning of the sine and cosine ratio in this figure. Okay. Okay. So similarly, you can try other tasks. Right? I set all the tasks in a more or less similar way. Okay. Just like the second one, I asked them to simply to continue. So this is a table that you can just enter. Okay, and then continue to input more value so that you can continue to complete this regular polygon. Right? Practicing again, entering the sine and cosine ratio. And the next one, I suggest a figure. Right? So you can turn off. That means hide the figure. And you can see that the purple one is basically based on this point, right, in a particular order. And the orange one actually are from the same point, but a different order, right? So you can check it. And now I invite the student to create another one, another star type figure based on these points, okay? And then you can just input some value to play with it, right? So that you can see how you can make use to create different kind of patterns and points, right? And similarly, the other one I also design in this way. And the other one, let me see, I asked the student to change some value. Maybe you can have try yourself later on, okay? And this one, I use a variable A, right? And so the student can enter some value in terms of A, okay? And then create different kind of polygon. And then the later one, I just give them a unit circle and a point on it and ask them to enter some value which they think has the same values of sine theta, right? Opposite or the same. That means 0.5 or negative 0.5. So they can drag around to find it if they are not familiar with it. I find the angle and then input it. Of course, somehow I hope that they will also have some estimation, right? Knowing approximately where to find the value and then input the answer here, right? And in the decimal platform, I can see the answer, right? So this is the way that I can collect the answer. Now I can show you let me see. I can show you the things I've tried with the student. This is another page I work with some students in secondary schools. And this is the drawing, okay? For the first one, many of them can complete the drawing here. Can you see this? Right? Some may be wrong. Let me see. I think this one is wrong. All right. So you can see some mistake here, 130 degree. To recognize it, all right? So, and the second one, they can complete the circle. I think this one is more interesting. Okay. So they are generating different patterns, just like this student. They are generating, this is the third table they enter. Do you notice that? So maybe I color in this one way, then you can see it. Okay, see this? All right. So they're practicing the drawing, right, together with recognizing the definitions of sine and cosine. All right, so these are different drawing from the student. So how about this one? I think it's the same kind of, same kind of drawing. And then this is created, the last one, right, the last figure here is created by the student. Right? I turn it into green. Right, so another pentagon. Actually, this one is a pentagon, right? So practicing the angle, right? Recognizing the angles in this environment. And so let me see. This one is also quite interesting. I asked the student to enter a square, right? This is a square, but it is not changing together with A. Okay, let's see another example. This one. No, this one is not. I forgot which one. Okay, this one can successfully do it. Right? So both are changing together with A. Can you see this? Okay. So these are some of the students' work. And then the later one is about sine, cosine, ratios. Okay, so you click inside this, then you can see the students' work. For example, the student can enter all the value, although they may not stopping at the point I want, all right? But it's up to them, right? I don't ask them to show me the angle. I just use this diagram, ask them to use this diagram to find the angles. Okay. Okay, so this is basically my demonstration, right? You can see another one if you like. I also prepare another set, the part 2. And it is a following lesson, right, of the previous one, which more complicated tasks, okay, based on unit circle and some symmetry of the angles. Okay. All right, so that is something I want to share today. And so basically, it is about some teaching ideas related to the unit circle and the trigonometric ratios definition, and making use of the GeoGebra tools and also the decimals tools as well. All right. So you can have a try and also think about the teaching ideas, because I think the teaching ideas may not be common in some of our textbooks, right? But you can share with me how you understand it or how you experience it yourself, like, and while you're learning this kind of definitions. Okay, maybe a demonstration can be finished here. Okay. So any question from you?
Thank you so much, Arthur.
Uh-huh. So any comment or questions?
Yeah, it's very impressive. I think students can interact with us very well if we're using this activity.
Mhm. How is it different or similar from your own learning of the trigonometric ratios?
When I